In this section, we will learn how to add and subtract radical expressions. Now let's simplify radical expressions involving addition and subtraction. The idea is similar to when you are adding fractions. For instance, if you have 1 over 2 plus 3 over 2, this is really 1 half plus 3 halves. 1 half plus 3 halves. So that's 4 halves. Okay, so you add the numerators, which is 2. Here, it's very similar. You're adding 3 radical 5s to 7 radical 5s. Okay, so what you can do is you can take the radical 5 common, add 3 and 7. So this is 10 radical 5s. So this is like similar to the common denominator. Same concept, not same thing, but same concept. Alright, let's make it a little bit more challenging. Here we have 2 radical 11 minus 1 radical 11. 3 radical 44. Now this is not the same as radical 11. It's similar when you have, for instance, 1 over 2 minus 3 over 2 plus, let's say, 4 over 3. You have 2 with the same denominator, but the third one has a different denominator. So you have to figure out a way where to make all the terms, make them have the same denominator. Here the same thing. We want this to have the same radical 11, all right? Now, 44 equals 4 times 11. So what we have here is 2, let's get rid of this, 2 radical 11 minus 1 radical 11 is 1 radical 11 plus 3. 44 is 4 times 11. Now 4 is 2 squared. Radical 4 is 2, or radical 2 squared is 2. So this becomes radical 11 plus 3 times the 4 comes out as 2. Okay, so this is radical 11 plus 6 radical 11. Now we have the same term, same radical term. So you can add them. Add or subtract to simplify each rational expression. Now, 12 is 3 times 4. Radical 12 is radical this. The 4 goes out as 2. Okay, so here we have the 5. This is the 5. Radical 12 is radical 4 times radical 3. Okay, we separated the 4 because the radical 4 would be 2. And you are left with 3y. So you have radical 4 times 3 times y. Okay, the 4 goes out as 2. And you're left with 3y. Now, you have 6 over here. Okay, this is not the 6th root, this is not the 5th root. This is 6 times. Now 75 is 3 times 25. That's 75. And you have a y. The 25 goes out as 5. That's why we separated the 25. And you are left with radical 3y. So this is equal 5 times 2 radical 3y plus 6 times 5 radical 3y. 10 radical 3y plus 30 radical 3y. Now we have the same radical term. Okay, so we can add them. 40 radical 3y plus 30 radical 3y. 10 radical 3y plus 30 radical 3y is 40 radical 3y. Over here, we have totally different radical terms that cannot be changed, that cannot be manipulated to get similar radical terms. 5 is a prime number, so radical 5 is radical 5. Radical 10 is radical 2 times 5. So this is radical 2 times radical 5. Still doesn't help, because the radical 2 here cannot be multiplied by this and then added to that. Okay, so this is gonna be equal 9 radical 5 plus minus 4 radical 2 radical 5. So now it's true here these are the same, but this is not the only radical term here. You have this, you cannot play with that. So we cannot add anything, right? Because if you take radical 5 common, you will have 9 minus 4 radical 2. These cannot be added because of the radical term. So this expression cannot be simplified any further. Simplify each radical expression. Assume all variables represent positive real numbers. Okay. Now the 32 here is 2 times 2 times 2 5 times. But we need 4 of them because we have a fourth root now, not a square root. So this is 2 to the power 4 times 2. I'm going to do a little bit slightly different. So this becomes minus 2, just keep it outside the whole thing. Okay, minus 2 radical minus 2, the fourth root of 2 to the power 4 times 2, minus 7, fourth root of 162 is 2 times 81 equals 2 times 81 is 9 times 9, and each 9 is 3 squared, so this is 3 to the power 4. Again, we needed the 4 because of the index. So this is 2 times 3 to the power 4. Okay. Ones with the same power and exponents, roots, they cancel out. So we have minus 2. This is 2. The fourth root is cancelled with the power 4. So times 2. And what's left under the fourth root is 2. Fourth root of 2. Similarly, you have minus 7 here. Similarly, we have 3 to the power 4, fourth root of that. They cancel out, so 3 comes out. And what's left is the 2. Fourth root of 2 equals, this is minus 4, fourth root of 2, this is 21, minus 21, fourth root of 2. Now we can add because we have the same radical term. So minus 4 minus 21 is minus 25 fourth root of 2. Of course, if you look at this, it's way simpler looking than the original one. Now this, we have third root, so we want to find something here to the power 3 and something here to the power 3. P to the power 4 is P to the power 3 times P. Q to the power 7 is Q to the power 6 times Q. Okay? We need something, let me say that again, we need something to the power 3 or something that is divisible by 3. Similarly here, now 64 is 4 times 4 is 16 times 4 is 64. Okay, 4 times 16, 4 times 10 is 40, 4 times 6 is 24. So that's 64. So this is the cubic root of P to the power 3, Q to the power 6, and we're left with PQ minus cubic root of 4 to the power 3, and we have PQ equals. Okay, P comes out P to the power 3 over 3. Q comes out to the power 6 over 2, so Q squared. And PQ still stuck under the cubic root, minus 4 to the power 3, cubic root of 4 to the power 3. So the 4 goes out, and this is cubic root, and you have this. Now we have the same root. It has to be exactly the same root. Same index, and same radicand. Same radicand. Same term under the radical sign. So we're adding PQ squared cubic root of radical PQ to minus 4 cubic root of PQ. Add or subtract to simplify each radical expression. Assume that all variables represent positive real numbers. Okay. We have a cubic root. So here we need to look for powers of 3 or powers exponents that are divisible by 3. Now 6 is 6 outside the radical sign. 16 is 8 times 2, because the 8 is 2 to the power 3. Okay. Z to the power 7 is Z to the power 6 times Z, because 6 divides 3. 4 is 4. 100, 200 is 100 times 2, because the 100 equal 10 squared, and there is a square here, that's the square root. Z to the power 4 times Z is Z to the power 5. we needed z to the power 4 because 4 divides 2. So now, this is 2z squared to the power 3. Along with the cubic root, they cancel out. Okay, and this is what we will have. So we have 6. This becomes 2z squared plus. This goes out as 10 and z to the power 4 over 2, z squared. Okay, I forgot this here, right? So I still need this cubic root of 2z. All right, plus 4 times radical 100 is 10. Radical z4 is z4 d to the power 4 over 2, so that's d squared. And we have radical 2z. Okay, this is radical 2z. Now, this is square root of 2z. This is the cubic root of 2z. If you simplify further, this is 12z squared cubic root of 2z. This is 40 plus 40 z squared radical 2z. Now, we cannot get any further. You could take z squared common. Okay, so you could do this z squared into this divides 4 and this divides 4, so you can take 4. The 12 becomes 3 cubic root of 2z plus the 40 divided by the 4 becomes 10, and the z squared is already here, radical 2z. Okay, there is nothing that can be done to these because this is cubic root, this is square root. Now, of course, you could put it in some different form, but this is an okay final form. Perform indicated operations. Assume all variables represent positive real numbers. All right. Here, we need to find common radical terms. Okay. 32 is 2. Keeping in mind that the power, the index is 2. Okay. So this 2 just multiplies the radical. The index of the radical is another 2 here. Okay, it's gonna be 2, 2, and so on. So radical 32 is 2 times 16. Radical 36 here, and 27 is 3 times 9. 108 is 3 times 36. Okay. Okay. What's the use of this? Because 16 is 4 squared. Okay. Radical 4 squared is 4. 9 is 3 squared. Radical 3 squared is 3. So now it's possible to take these outside the radical sign. Same thing here. Radical 36 is 6. Radical 36 is 6. So what we have here is 2 times 16 becomes 4, radical 2 over radical 36 is 6 plus 2, radical 9 is 3, radical 3, this 3 stays under the radical sign, Radical 36 is 6. And this 3 stays under the radical sign. So now we can cancel these. So this is 2 times 4 is 8. 8 over 6 is 4 over 3. So this is 4 over 3. Radical 2 plus 2 times 3 is 6. Divided by 6 is 1 plus 1. And that's as far as we can take this. Performed indicated operations. Assume that all variables represent positive real numbers. Again, you have this. So we start with the first one. Again, we have a square root. Okay. 80 is 5 times 16. Okay, 5 times 10 is 50. 5 times 6 is 30, so that's 80. 5 times 16. The 16 is 4 squared. So that's why we need it. This is already in good condition because you would have 4 over 2. Remember, this is 2 here. Now 81 is 9 squared. Okay, so this is going to be radical y to the power 4 radical 4 squared times 5 plus radical 9 squared over radical y to the power 10. So these are fine, this and this, because they divide 2. Equals. This 4 squared comes out as 2. Radical 5 is stuck in under the radical sign. This is y to the power 4 over 2, so it's y squared. This is 9 plus 9, and this is y to the power 10 over 2. So this is y to the power 5. Okay. Now this is equal. Common denominator is y to the power 5. Okay, but we need to multiply this by, okay, let me give myself some space. Okay, you need to multiply this by y to the power 3 over y to the power 3. This becomes y to the power 5. And we did not change the term because we multiplied by 1. So, 2y cubed radical 5 plus 9. This is now y to the power 5.